Well, here we are, the very end of this extremely long unit on formulas. This final topic will take your converting grams to moles and apply it to other things that you can convert to or from moles. However, the math is identical, whether you're converting grams to moles or liters to moles or number of molecules to moles, the math is exactly the same. What the heck is this thing called a mole? I've been mentioning it all year long, but what is this mole thing? A mole of any substance weighs its atomic or formula mass in grams. That's where gram formula mass comes from. It occupies a volume of 22.4 liters if it's an ideal gas at standard temperature and pressure. And it will contain 6.02 times 10 to the 23rd atoms or molecules or ions or formula units of that substance. 6.02 times 10 to the 23rd is Avogadro's number, and it's the number of atomic mass units needed to weigh 1 gram. Basically, we say we have a mole of substance instead of saying we have enough atoms for it to weigh its atomic mass, or we have enough gas for it to occupy 22.4 liters. We just say 1 mole of it, like we'd say I have a dozen eggs. So if you want to convert 2 moles, what you do is you divide by the conversion factor so that whatever you're converting cancels and leaves you with moles. And if you want to convert from moles, you simply multiply to cancel out the moles and be left with whatever unit you're trying to solve for. So what does that look like exactly? Well, let's create a little mole map to sort of suss it out for us. We can convert everything to moles. We can convert mass in grams to moles, liters of ideal gas at STP to moles, and the number of particles to moles. And we can convert them not only to moles, but from moles, which means that we can use moles to convert them to each other. So I can convert the mass in grams to the liters of gas at STP if I first convert to moles and then convert to liters. To convert to moles, we divide. And we divide by whatever the conversion factor is. To convert from moles, we multiply. The conversion factors are the number of grams per mole, the gram formula mass, to convert between grams and moles. You already know this. 22.4 liters per mole to convert to and from liters and moles. And 6.02 times 10 to the 23rd molecules, formula units, or atoms per mole to cancel those out and get moles, or cancel moles out and get that. So if I want to convert, let's say, from number of molecules to grams, I would take my number of molecules, I would first divide it by 6.02 times 10 to the 23rd particles per mole. This would cancel out particles and leave me with moles. Then I would multiply by the number of grams per mole. Moles would cancel, and I'd be left with grams. So think of moles as sort of the central switching station. You can get anywhere if you go through moles. We have a sample of O2 gas at STP, has a volume of 44.8 liters. What is the mass of this sample of gas? Well, what we're given is liters of ideal gas. We have to convert that to moles, and to do that, we divide by 22.4, because dividing by 22.4 will cancel out liters and leave us with moles. And yes, significant figure still applies. 3 sig figs, 3 sig figs, 3 sig figs. That's why I'm not just leaving it as 2. I'm leaving it as 2.00. Now we're asked to convert that to mass, so we're going to have to convert moles by multiplying by formula mass to grams. Well, oxygen has a mass of 16.0, so 2 oxygens will have a mass of 32.0. When we multiply 2 times 32, we get 64, but 3 sig figs, 3 sig figs, 3 sig figs in our answer. So 44.8 liters of oxygen gas at STP will weigh 64 grams. What about nitrogen? Well, nitrogen has its own formula mass. So you're going to have to do this for each. See, it's always 22.4 liters per mole. It's always 6.02 times 10 to the 23rd. But for mass, you're going to have to find the gram formula mass before you use it. How many liters of nitrogen are required to have 1.81 times 10 to the 24th molecules of nitrogen at STP? So we're given 1.81 times 10 to the 24th molecules. Before we can convert it into liters, we have to first convert it into moles. And we do this by dividing by 6.02 times 10 to the 23rd molecules per mole, because doing that will cancel out molecules and leave us with moles. 3 sig figs, 3 sig figs, 3 sig figs. Now that we have moles, we can convert that easily into liters by taking those moles and multiplying it by 22.4 liters for each of those moles. So when we multiply it by 22.4 liters per mole, the moles cancel and leave you with, well, again, 3 significant figures throughout. So 3 significant figures in your answer. Convert to moles and then convert from moles. 4 grams of sodium hydroxide are used to make a base solution. How many formula units of sodium hydroxide are in the solution? Now, I'd use the word molecule, except you can't apply the word molecule to an ionic compound. Only molecular substances get to use the word molecule. So we use the word formula unit instead of molecule when we're describing an ionic compound. We're given grams, 4 of them. Well, 4.00, because we don't want to mess with our sig figs. Before we can convert them to formula units, we first have to convert them into moles. To convert to moles, we need to divide by the gram formula mass of NaOH. Na is 23.0, O is 16.0, H is 1.0, for a total of 40.0 grams per mole. When we do this, we get, well, again, 3 sig figs, 3 sig figs, 3 sig figs. Now that we have moles, we can easily get to the number of formula units by multiplying by the number of formula units in a mole, by multiplying by 6.02 times 10 to the 23rd formula units per mole. When we do this, we get 6.02 times 10 to the 22 formula units. So for chemical engineering purposes, it's really important to be able to convert to and from moles to anything you want. And it's a very straightforward process. You want to convert in such a way that the units you start with cancel and leave you with the units you're looking for, so that the units you start with cancel and leave you with the units that you're looking for. Conversion factors. Remember, I said they make up about 50% of all the math in this course, and that's all this is. Doing multiple conversions. It would be sort of like me asking you, how many inches are there in 36 yards? Well, first you'd have to convert your inches to feet, and then you'd convert your feet into yards. Okay, so there's 2 conversions. Now, if all they're asking for is converting to moles, then just do the one step. And that's all there is to it. In the next unit, we're going to put all this together to do chemical reactions. And you'll actually be able to know, what do I get when I react these things together? It's actually really cool. But that's for another day. And so for now, have yourselves a delightful day. Stay well. Give my regards. Take care. And most importantly, bye.